Hey guys, welcome to day 7 of pre-cal. Today we're going to be reviewing some right triangle trig. We've actually seen this before in geometry, so you might recognize some of what we're going to be talking about today. This does begin a new unit as well, and this will really kick off our beginning to a lot of the trigonometry we're going to be doing this year. All right, so let's go ahead and review some of our trig ratios. So we can relate the angle measures of triangles to their side lengths, and we do so using these trig ratios. So we have sine is opposite, or sine of the angle measure is equal to the opposite side length over the hypotenuse, and you can see that we have labeled those here on the triangle. We get opposite, hypotenuse, adjacent, etc. Based on where our reference angle is. So our reference angle is here in the left-hand corner. So that is why across from that angle, that's the opposite side, right next to the angle. The side length that is touching it is the adjacent side length, and the longest side length of our triangle will always be the hypotenuse. And guys, it is really, really important that we recognize that it has to be a right triangle for us to be able to use these trig ratios. All right, so we have all these different trig ratios: cosine, tangent, cosecant, secant, cotangent. Cosecant, notice that that is just sine flipped around. Secant is cosine flipped around, and cotangent is tangent flipped around. So those are related to one another. A little trick to help us remember these trig ratios, we call it SOHCAHTOA. Okay, and so that just helps us remember these trig ratios. So it stands for sine of the angle is opposite over hypotenuse, cosine of the angle is adjacent over hypotenuse, and tangent of the angle is opposite over adjacent. All right, and then the other three trig ratios would just be these flipped around. Okay, so let's do an example. Find the 6 trig ratios of the angle. All right, so this did get a little cut off. That's supposed to be like that. Okay, so let's just start off with, well, first let's label all of our sides. So since our reference angle is down here in the bottom left-hand corner, that means that 6 is the adjacent side, 3 is the opposite side, and then over here is the hypotenuse, just like in our picture above. All right, let's start with sine. So sine of that angle is going to be the opposite side length, which is 3, over the hypotenuse side length, which is 3 root 5. Okay, we do want to simplify these as much as we can. So first off, I see that this 3 in the numerator and in the denominator can be canceled out, since 3 divided by 3 just is 1. So that leaves me with 1 over root 5. And then guys, something that we're going to be doing a lot in this class with the unit circle, which we will talk about, is next time a lot, which... Yes, we're going to talk about the unit circle next block more in depth, but we do need to do something we call rationalizing. So we need to make sure that there are no radicals, meaning the square root symbol, in the denominator. So how do we get rid of a radical in the denominator? Well, what we want to do is, if we want to get rid of a square root symbol, what we can do is multiply it by another square root of 5, but what we do to the denominator, we have to do to the top. And why is that? Well, when we multiply 2 square roots together, we can multiply what's underneath. There's a property that tells us, hey, we have 2 square root symbols, so we're multiplying. That means we can combine them under 1 square root symbol. Okay, Okay, so notice how I combine 5 times 5 underneath the square root. Well, 5 times 5 is 25. And square root of 25 is 5. So essentially, if we multiply by the same number with the square root, so the same thing in the denominator, we could have, without doing these last two steps, automatically known square root of 5 times square root of 5 would be just 5 by itself. Okay, and notice there's no longer a square root in the denominator. All right, so I'm going to kind of more quickly go over the others. So now we have cosine of the angle. That's going to be the adjacent side over the hypotenuse. Okay, once again, 6 over 3 can be simplified to 2 over 1. So now there's a 2 on top. And we want to get rid of that square root symbol in the denominator. So just like I did before, oops, need to delete that. So just like I did before, I'm going to go ahead and multiply the top and bottom by square root of 5. And that'll get rid of my radical in the denominator. So on the top, 2 times square root of 5, that can't really be simplified at all. And then the denominator, it'll just be 5. Alrighty. Now let's do tangent. Tangent is opposite over adjacent, so that's going to be 3 over 6. In other words, 1/2. Okay, we do need to do the other ones, so when I go ahead, well, tangent, opposite of tangent is cotangent, so I'm just going to flip around my final answer for tangent to be 2 over 1, which is 2. Now, opposite of cosine is secant. So I'm just going to flip around the secant. Now, I'm not going to flip it around for my final answer because then I'll be left with a radical in the denominator. Instead, before I got rid of that radical, I had 2 over square root of 5 right here at that step. So I'm just going to take that, flip that around, because that leaves me without a radical square root symbol in the denominator. And so then the same thing with sine. So cosecant's opposite of that. I'll just do that one. Oopsies. I'll just do that one right here. So I'm looking at sine. Before I got rid of the radical in the denominator, it was 1 over square root of 5, this guy right here. So if I just flip that around, that's going to be square root of 5 over 1, which is simply square root of 5. All right, so we have now found all 6 trig ratios. All right, let's look at the next example. It said if sine of an angle, which we're going to call, this symbol means alpha, sketch a right triangle with acute angle named alpha, and find the other 5 trig ratios. Okay, so first off, we do know that we have to have alpha be an acute angle. So if I go ahead and draw a picture, remember the fact that it says right triangle is extremely important. We needed that piece of information to even be able to do this in the first place. So I'll make that my right angle, just like the 2 pictures above, and I'll make this angle be my acute angle alpha, again like the pictures above. So that was my reference angle. And so the other piece of information it gives us is that sine of this angle is 1 over 3. Well, sine, we know, is opposite over hypotenuse. Think of the so in SOHCAHTOA. Okay, so I'm going to label the opposite sides, the opposite side of my angle alpha, that 1, and the hypotenuse, 3. And now I need to find my adjacent side. and in order to find the other 5 trig ratios. Okay, well, first off, how do I find what that side is supposed to be? So you might remember when we were working with these right triangles that we have Pythagorean's theorem. So that will help us find missing sides of a triangle. All right, so that theorem is, going right here, a squared plus b squared equals c squared. Okay, so a and b just stand for 2 sides that I have. I have 1 and 3. So I'm going to I need to specify C, guys, has to be the hypotenuse. Okay, so A and B are the 2 side lengths that are not the hypotenuse. Okay, so this, we can name this A, this could be B, this could be C. Okay, so notice C is my hypotenuse. Okay, so if I substitute in the values that I have, I'm going to substitute 1 in for A. I don't know B yet, but I know C. Okay. Well, next step, 1 squared is just 1 plus b squared equals, and then 3 squared is 9. I still need to solve for b, so I'm going to subtract 1 over. So that would leave me with b squared is equal to 9 minus 1 is 8. Take the square root of both sides. And since, guys, we're working with a triangle here, don't worry about when I'm taking the square root of this 8, adding a plus or minus in front. My side length has to be positive if we're talking about a side length. It can't be negative. Okay, so b is square root of 8. We do want to simplify that as much as we can. And so we know that we're trying to think, okay, what is a multiple of, not a multiple, what's a factor of 8 that has a perfect square root? So that would be 4. Okay, so I'm breaking down 8 into 4 times 2. Why did I do that? Well, because there's a property that tells me if I'm multiplying these 2 numbers together, I can, and one has a perfect square root, I can take out that perfect square root in front here. So square root of 4 is 2, so I'm going to take out the 2 in front, and that leaves me still with the square root of 2 in the denominator. Okay, so this missing side length b here is 2 root 2. Now we can officially find all of our other trig ratios. Okay, so we already have sine. That makes it really easy to find cosecant. I'm just going to flip around what it is for sine. So 3 over 1, or in other words, 3. Next we have cosine. Alpha, so k adjacent over hypotenuse, and so k toa adjacent is 2 root 2 over hypotenuse, which is 3. There's no radical in the denominator, so I'm good to go here. Then I need to find secant, which is opposite of the cosine. So I'm going to flip around my cosine. So now I have 3 over 2 root 2. And again, I need to get rid of that square root 2 in the denominator. How do I do that? Just like last time, multiply by the same exact square root. So on top, that leaves me 3 times root 2. And the denominator, square root of 2 times square root of 2 is just 2. But we still have that 2 hanging out in front. So now we have 2 times 2 in the denominator. And that would be 4. And we can't simplify that 3 over 4, so we're left with this. All right, now let's do tangent. Opposite over adjacent, so that would be 1 over 2 root 2 So same thing, I need to get rid of that square root of 2 in the denominator. So in the numerator, 1 times square root of 2 is square root of 2. Don't forget I had to do it on the top because what we do to the bottom, we have to do to the top. Make sure we don't change the value of this fraction, this ratio. And then the denominator, same as before, we're going to end up getting 2 times 2, which is 4. Okay, and then I need to find the last one, cotangent. That is just tangent flipped around. So I'm going to flip it around from the beginning before I got rid of my square root symbol in the denominator. So 1 over 2 root 2, that's what I'm going to use to flip. That'll give me 2 root 2 over 1, or in other words, just 2 root 2. All right, guys. Let's move on to the next example. All right, it says, solve this triangle, find all missing sides and angles. So guys, if you are asked to solve a triangle, exactly what you're doing is finding the missing sides and angles. Okay, so if you see solve the triangle, but you don't see the sentence that follows, find all missing sides and angles, you know that that's what you're supposed to do when it says solve a triangle. Okay. So, first off, we need to go ahead and find, we know we have one angle, we know we have one side, okay? So we are going to actually use the fact that we have the angle inside to find our other missing piece of information. Now this, guys, we do need, technically we won't end up needing graphing calculators all the time to find what an angle measure is at a certain side length. But we haven't done the unit circle yet. So we haven't yet talked about how we can find out what certain trig functions at certain degrees are yet, but we will be able to actually solve for those without having to use a graphing calculator. But for our purposes now, if you have a graphing calculator, I'd pause the video. You can run and grab it, and we're going to need it in just a sec. If you don't have a graphing calculator, again, do not worry too much. We will talk again about how we're going to be able to find, for instance, what sine of 60 degrees or tangent of 60 degrees, etc. would be without a calculator. Okay, now if you have a calculator, make sure you're in degree mode. So you're going to hit the mode button. So you're going to hit the mode button, scroll down a couple, and hit degree. So we need to make sure we're in degrees, not radians. Okay. So it is absolutely essential to do that at this point if we're going to be able to find all of the other side lengths and angles. Okay, so first of all, I'm going to go ahead and write down all the things that we're going to find. We're going to end up finding measure of angle A, measure of angle B, measure of angle C. We actually know measure of angle B, it's 60 degrees. And then we're going to find the side lengths A, B, C. For the side lengths, guys, those are opposite. They're capital letters for the angles. So we see here B is on top, so across from that, this would be side length B. Across from angle A, this would be that side length. And then across from the right angle, that's going to be angle C. Now we do have one other piece of information, guys. We know that that is 90 degrees. Okay, so without doing yet any math, I know that, so I'm gonna go ahead and write that in. Now, if you recall, all of the angles in a triangle add up to 180. So I'm gonna add up my 90 and my 60 and subtract from 180. Whoopsies. So if I add up all these angles together, it'll equal 180. So now when I do 180 minus 90 minus 60, I'm gonna get 30. So angle A is equal to 30 degrees. All right, I've now found all of my angle degrees measures. Now I need to find the sides, and so really, sorry, one sec, guys. I need to run and grab something real fast. Okay, sorry about that. Okay, thought I had my graphing calculator over here, and I do not. All right, so let's go ahead and find the other side lengths. We know, let's go ahead and find, we could find either one. First off, we do know the side length C is 6. I forgot to write that down. Okay, so I'm gonna go ahead and find A first. Why not? So if I'm trying to find side length A, okay, then I want to think, okay, first off, what's going to be my reference angle, okay? I could either use angle A for the 30 degrees that we found, or I could use angle B. I cannot use the 90 degrees, okay? So when we are doing right triangle trig, you might want to write this down. Can't use the 90-degree angle to solve anything else. Okay, so it has to be one of the acute angles. Okay, so I'm just going to go ahead and use what we were given with starting out, so the 60 degrees. So first off, if I'm looking for angle A, and I'm going to use the reference angle 60 degrees, okay, well, angle A is adjacent, okay, that angle B of 60 degrees. Oops, I think I said angle A. Side length A is adjacent the 60-degree angle. And then if I want to use, if I don't know what B is yet, right? So I have to use the fact that the hypotenuse is 6. Okay, so the hypotenuse is 6. I'm finding A, which is adjacent to angle B, my reference angle. So I'm going to use cosine. Cosine is adjacent over hypotenuse, and that's what I have. A is adjacent of 60 degrees. And then we're also using the hypotenuse, which is 6, because that's the only other piece of info we have. Okay, so cosine, I'm using the 60-degree angle is equal to the adjacent side length, I keep doing that, over the hypotenuse. All right, and so now when I want to solve for A, first off, I need to find what cosine of 60 degrees is. So specifically, guys, that is 1/2. Again, we will go over how we're gonna be able to know that without even using a calculator at all. But if you do have a graphing calculator and you're in degree mode, again, degree mode, press cosine 60 and you'll see it's 0.5. Okay, so calculator can give it to us as well. Okay, so cosine of 60 degrees is 0.5, or in other words, 1/2. And so when I go to solve for A, multiply by 6 on both sides, and 6 times 1/2 is 3. All right, so I just found another side length, and now I'm going to find side length B. Okay. So if I'm going to solve for side length B, and again use my 60 degrees, so angle B as my reference angle, well, that means that angle B is opposite of side length B. So I want to use the opposite side, and I'm also going to use, once again, what we were just given in the beginning, so the 6, which is the hypotenuse. So if I have the opposite side length and the hypotenuse, so is what I'm going to use in SOHCAHTOA. So sine of my angle 60 degrees is equal to the opposite of that angle B, so which is going to be side length B, over the hypotenuse, which is 6. So just as before, first we're going to find what sine of 60 degrees is, and that is, if we put that in our calculators, about 0.866. And then solve for B, and we get that it's about 5.2. If you ever see me do these squiggly equal signs, that means approximately, since we rounded that decimal. All right, so the last side, 5.2. And we are done. We have all the side lengths and all the angle measures. All right. So now let's learn a couple of vocabulary words that we're gonna be using throughout this year. So angle of elevation, okay, that's the angle between the horizontal line of sight to an object above the horizontal. And then angle of depression would be an angle between the horizontal line to the line of sight to an object below it. So for example, if I were to draw a picture, and let's say for angle of elevation, we have this horizontal line. And if we're looking at an object, so let's say we're a person, maybe we're standing here, and we're looking up at an object, well, the horizontal line from where our eyes are, so if we're looking straight ahead, let's just pretend there's a parallel line to the ground shooting out of our eyes, and that's this horizontal line. And then if we were to look up at something, our eyes would then go up and create this angle of elevation here. And so notice that angle was created by a line going up from the horizontal, whereas angle of depression would be an angle created downward from the horizontal line. Okay, so let's do an example. A large tree casts a shadow that is 200 feet long. Find the height of the tree if the angle of elevation is 20 degrees. So I'm just going to go ahead and draw a picture. Don't judge my picture. Okay, so this is my large tree. Yeah, that's just great. Okay, so there's my large tree. It casts a shadow that is 200 feet long. So if I'm thinking about what a shadow would look like from this tree, okay, this is the shadow and it's 200 feet long. So now we're going to find the height of the tree if the angle of elevation is 20 degrees. So I'm going to use this 200-foot shadow as my horizontal line. And so my angle of elevation, imagine Imagine standing right here and looking up at the tree. Okay, so if I want to find the height of a tree, imagine that we're thinking about where we are at the ground and we're looking up at the tree. Okay, and so that angle of elevation that we just created, notice my pen went up when I created this angle here, is 20 degrees. Okay, and that was given. Okay, so now we want to find height of the tree. So I know I have an angle. I do know, we're just gonna, assume that this angle created right here is 90 degrees. It would be about right, from the tree to the ground. Tree might not be perfectly standing upright at 90 degrees, but for this example, we will assume it is as such. All right, well, I have an angle. I have the adjacent side to the angle. I know that's 200 feet. Okay, so the adjacent side I have, and I'm looking for this opposite side, so the height. So if I have the adjacent side, I'm looking for the opposite side, that would be TOA. Tangent of the angle is opposite over adjacent. So this is, again, a handy place to have our calculator. So tangent of 20 degrees is going to be 0.36397, etc. So I'll go ahead and round that to be about 0.364. And now multiply by 200, and I get that my height is, and I rounded on the paper, but I didn't actually round in my calculator, so just FYI. Okay, so this decimal multiplied by 200 is about 72.79. Don't forget your labels. We are talking in feet here. All right, there we go. We just found the height of the tree. All right, let's do another example. So a woman is standing on a hill. I'm just going to go ahead and draw that. We have a hill. We have a woman. Yay. Okay. And she sees a flagpole that she knows is 60 feet tall. Okay. Well, that flagpole is obviously touching the ground. And she's looking up at it from this hill, okay? And so she knows that the height of this flagpole, whoops, sorry guys. All right, my apologies. Okay, so we know the height of this flagpole is 60 feet tall. Okay. And then it says the angle of depression to the bottom of the pole is 14 degrees. Okay, so remember earlier when I was talking about angle of elevation, imagine you're looking straight ahead, and imagine there is a parallel line to the ground shooting out from your eyeballs. Okay, so that parallel line I'm going to represent with this dashed line. Okay, it's parallel to the ground. So if she's looking up at the top of the flagpole, that is going to be the angle of elevation. And if she's looking down at the bottom of the flagpole, that's going to be the angle of depression. So this angle from the horizontal line looking down at the bottom of the pole is the angle of depression. So we were just told that's 14 degrees. And then it says the angle of elevation to the top of the pole is 18 degrees. So this angle right in here is going to be 18. Okay, so the entire measure of this whole angle is 32. Okay, so what we're going to end up having to do is we want to make sure we're working with a right triangle to even be able to use trig. Well, I have, in a sense, just created two right triangles, creating this line that's parallel to the ground. So I'm going to treat this like two different triangles. Okay, I have my triangle on top, and then I have my triangle on the bottom. Okay. All right, so that means I'm also working, so first off, what am I trying to find? I'm trying to find how far she is from the pole. So I'm trying to find this distance right here from her eyeballs to the pole. That's what I'm aiming to find, okay? All right, so I do need some pieces of information in order to be able to find that distance. I have a couple of side lengths. I don't know what they are yet, but I'll find out. So I have this side length right here. We'll call it height 1. And then I have this side length right here, height 2. I know something about these heights. I know if I add these two heights together, it's going to equal this 60 feet. Okay. So I'm going to go ahead and write that down. Okay, so I know that much. All right. Now, let me just put together what we know so far in a trig ratio. Okay, so working at the top, off of my top triangle, I have that my reference angle I'm going to use is this 18 degrees. Again, remember, you can't use the 90-degree angle as your reference angle in your trig ratio. Okay, notice I'll never write tan of 90 or cosine of 90 to find a side length, okay? All right, so 18 is my reference angle. I know I have the height, which is opposite of that angle, and I also have what's gonna be my final answer, the distance to the pole, which is D, and that's adjacent my 18-degree angle. Okay, so height 1's opposite, the distance D is adjacent, so opposite and adjacent, we want TOA tangent. All right, so I have tangent of 18 degrees equals opposite over adjacent. Opposite of 18 degrees, whoa, is the height 1. Adjacent is that distance D. All right, and very similarly, if I'm looking at my bottom triangle and using 14 degrees as my reference angle, I have opposite of the angle, which is height 2. I also, again, they share that same side, that distance D to the pole. So tangent of 14 degrees is opposite, which is the height 2, over the adjacent side length, which again is that D, the distance. Okay, so what I want to do, guys, I'm going to try to manipulate these two trig ratios to somehow let me be able to figure out what our side length D is. Okay, so I'm gonna kind of just move these around. Again, I know what height 1 plus height 2 is. So what if I could get these trig ratios to be equal to height 1 and equal to height 2 on the bottom, and that way I could add the two trig ratios together, and I know that then added together they would equal 60. Okay, so let me show you what I'm talking about here. So first off, if I multiply by D on both sides to solve for H1, okay, I'm going to get that D, why did I keep doing that? D times tangent 18 equals height 1. And then if I do the same thing on the bottom, solve for height 2 by moving D to the other side, I'm going to get d times tangent of 14 equals height 2. Okay, well, I know that if I add these two together, height 1, so I'm going to add them together. So if I add d tangent of 18 plus d tangent of 14 degrees, that's going to equal this height 1 plus height 2. Okay. All right. Well, the whole thing that I'm trying to find right is the side length. The d is d. So what I want to do is try to isolate that variable d. Okay. So how do I do that? First off, I have d in both terms here. It's being multiplied to tangent in both terms, so I could actually take out d in front as a common factor. So if I take away d, that's just going to leave me with tangent 18 plus tangent 14, kind of like reverse distributing. Notice if I were to distribute this d back out, I would just end up where I started with. And then we know h1 plus h2, we know what that is. We know that that's 60. All right, so we're getting somewhere. Well, again, I want to isolate d, so I'm going to try to get rid of this tangent of 18 degrees plus tangent of 14 degrees. So it's being multiplied to d, so I'm just going to go ahead and divide. So if I divide by tangent 18 plus tangent 14, that's going to leave me with d is equal to 60 and divided by tangent 18 plus tangent 14. All right, so now you have everything you need to know. You can put this in your graphing calculator. And I should have said this earlier, guys, but there's lots of resources for graphing calculators, apps for them. Really, you just need the trig functions for this unit. So you can also download an app, or if you maybe like to check one out or something, you could let us know and we can see what we could do. Okay, so if I do 60 divided by, and then in the denominator, make sure to put parentheses around your tangent 18 plus tangent 14. We're gonna get, oopsies. About 104.5. And we are working in feet here. And so we have our final answer. All right, guys. So yes, that was a little bit more of a trickier one. We had to do some maneuvering, in order to get that final answer. So that was definitely a little bit one of the trickier ones that we're going to work with. All right, these next ones, though, are pretty straightforward. We're just solving the following triangles. So I'm just going to do one of these, and then I'll write the answers to the others. And I recommend that you try them on your own. First off, I recommend pausing the video, trying it on your own anyway, but just for time purposes, I know it's kind of a long video, I'm just going to work out one of these and give you the answers to the other two. And if you're not sure how I got those answers and you can't find them, please see us in tutorials. Okay. All right, so I'll actually work out, I'll do C down below since it has the most room. All right, so first off, I'm given 2 side lengths. That's for all of these, given 2 side lengths, and I need to find the third side length as well as all the other angles. Okay, so let's see. Remember when it says solve a triangle, what we're looking for are all of our angle measures and all of our side lengths. I'm gonna go ahead and make sure my triangle is fully labeled. So the side length A is across from angle A. Side length B is across from angle B, which we know is 5. And side length C is across from angle C, which we are given is 10. Okay, if we want to find side length A, we can use our handy dandy Pythagorean theorem. As always, you can use that if you have two side lengths and a right triangle. We need a right triangle to do any of this, and notice we do have that here. All right, so to find side length A, the Pythagorean theorem I'm going to use, well, we're given the hypotenuse, and then our A and our B are these shorter side lengths. So we have A squared plus B squared equals C squared. So A squared, well, that's the side length I'm trying to find. B squared is my shorter side length, so that 5, that does actually happen to be side length B. And C squared in the Pythagorean theorem is always the hypotenuse, and that hypotenuse here is 10. Okay, so if I start solving this, 5 squared is 25, 10 squared is 100. So 10 squared, 100 minus 25 is 75. And then square root of 75 is going to be about 8.66. I'll just round it to 8.7. All right, so I just found my third side length. Okay, now I want to go ahead and find the angles. So we're going to do what we were doing a little bit earlier with the example up above. So first off, we do already have one side or one angle measure. That would be measure of angle C. That's given to us as a right triangle. So we already know that that is 90 degrees. All right, so let's go ahead and find the measure of angle A first. Okay, so guys, I highly recommend that you use information that was already given to you when solving for angle measures. Don't use the 8.7 that we just found to be side length A. That's a rounded answer. Use the exact numbers we're given, 10 and 5. So if I'm using these numbers 10 and 5, well, 10 is the hypotenuse, 5 is adjacent, my angle A that I'm solving for at the moment. So adjacent and hypotenuse, that is going to be cosine. All right, so I have cosine of angle A is equal to adjacent over hypotenuse. So 5 over 10, or in other words, 1/2. Okay. Again, this is actually an angle measure that when we learn the unit circle, we'll actually be able to find out without using a calculator at all. But for our purposes, let's pretend we don't yet know that. And let's pretend we're going to use the calculator for this one, okay? So if we're solving for an angle and we're given the side lengths, we're going to be using inverse trig, okay? And essentially that's because we want to get the angle measure, right? We want to isolate this angle A, but right now we have cosine attached to it. Okay, so we have to get rid of cosine. Well, how do we get rid of cosine? Well, think about just, little side example down here. If we have, let's say 1/2, equals blah, 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 1/2 x or something. And we're trying to, let's say 4, I'm just making this up. Let's say, right, we have something like this and we want to solve for x. Well, how do we get rid of this 1/2 in front of x? Well, we multiply 1/2 by kind of like what we can think it's opposite, right? It's reciprocal. So we would multiply by 2. right? Because we know that 2 is the inverse of 1/2 and they cancel out, and that's how we're left with just x, right? So trig functions have the same thing, right? We have inverses that help us to get rid of them, be able to kind of cancel them out, as we say, like I just did. So inverse trig, if you have a calculator and you're looking at it, notice right above the sine, cosine, and tangent, you see sine with a little it looks like to the -1, but really it means inverse. And they have the same thing above cosine and tangent. So those are what we use to get rid of the trig functions so we can solve for the angle. Okay, so I have here cosine of A equals 1/2. I want to get rid of cosine, so I'm going to multiply by the inverse of cosine. Notice I'm using this little symbol. It looks like to the -1. And what I do to one side, I have to do to the other. So I'm also going to multiply by the inverse of cosine on the right-hand side. All right, well, on the left-hand side, cosine times the inverse of cosine, those cancel each other out. Okay, they're opposites of one another. All right, so then we're just left with A on the left-hand side. And on the right-hand side, we have the inverse of cosine times 1/2. All right, so now this is where we're going to take our calculator. You want to hit the second button and then cosine. In your calculator. Okay, so when you do that, notice it pops up cosine with like the little -1, which it doesn't, what appears to be an exponent, that's what I'm trying to say, to the -1. So you should see that on your screen, and then type in 1/2 or 0.5, and when you hit enter, you should get 60. And so that would mean here that angle A is equal to 60 degrees. Okay, so I just added that in our info. Okay, now let's go ahead and do angle B. So in similar fashion, I want to use the pieces of information I'm already given. First off, we know that angle C, or angle A is 60, angle C is 90. Yes, we could add these two angles up. And then subtract them from 180, and that would give us angle B. And so angle B we do already know from what we have found thus far to now be 30 degrees. Okay, so that is absolutely how I'd recommend doing that on a test. But just for a little bit more practice with this inverse trig, let's go ahead and just solve it like we did for angle A. Okay, so again, we have angle B. If we're looking at what the information already given, the 10 and the 5, 10 is the hypotenuse. This side length 5 is opposite of angle B, so we're going to use sine, opposite and hypotenuse. All right, so sine of angle B is equal to opposite of angle B, which is that side length 5, over the hypotenuse, which is 10. So again, we have 1/2. All right, so sine B is equal to 1/2. Okay, same thing. I want to get B by itself, so how do I get rid of sine? I multiply by the inverse of sine on both sides. So that will cancel out my sines on the left-hand side, and I'm just left with angle B equals inverse of sine times 1/2. All right, so in our calculator, if we hit second sine, you should see this notation pop up. Okay. and that inverse sign of 1/2 leaves us with 30. So angle B is equal to 30 degrees, as we just found when we subtracted from 180. All right, so now we have found all of our info that we need. Okay guys, so just a little recap. If you are solving if you're given an angle measure and you're given some side length measures, you can do a lot like we did in this example right here, right, where we use those angle measures and side lengths to solve for a missing side. That doesn't involve any inverse trig. But if you are given side lengths and we don't know the angles, right, we knew 90 degrees, but again, we cannot use 90 degrees in our trig. So if you're given side lengths and you're solving for the angle, then that's a really good indication, hey, I know I need some inverse trig. Okay, so the answers I told you I would write down up here for these A and B. So measure, or actually I'll just write them on the triangle. So measure of angle A, that's going to be about 24.6 degrees. C is obviously 90. And then measure of angle B is going to be about 65.4 degrees. And then our missing side length here that we don't have is 10.9 about. Okay. All right, part B, measure of angle A is, so this angle right here, that's going to be 58 degrees. Again, guys, I recommend actually do A and B. See if your answers match mine. If they don't and you don't know why, check over your work, but you can also see us in tutorials if you can't figure it out. All right, measure of angle B is 32 degrees. And then this missing side length is going to be 9.4. All right. Okay, guys, so that's going to conclude our right triangle trig lesson today. Again, please make sure to do any assignments if given after this video. All right, guys, and make sure to come to class next time prepared with this having been watched and taken really good notes, okay? Because we do need to know this stuff for the rest of the year. This will be pretty much the standard basis of what we're working with for a long time. All right, guys, well, y'all have a great day.